Hello.
Hello,
Hi, how are you?
I'm good. How are you?
I'm great too, thank you. Do you mind turning on your camera, please?
I don't mind. It's just let me see if I can find it.
hmm
Oh,
What's your
is
name?
it Maisha?
Maisha. That's quite a unique name that I'm hearing. What's your
Can you see me? Because I can't. I don't know if you can see me or not.
Yes, yes, I can see you totally. I can see there are blue lights behind you.
Yeah. Okay. Yeah.
Yeah. So still up with the New Year celebration?
Yeah.
Really? That was for New Year's.
Huh? Oh no, these are like LED lights.
hmm But that's what I'm
Yeah.
asking. Are these like your permanent room lights or they were up
Uh,
just for the New Year celebration?
no, they're like you can change the color on them.
Oh, all right, all right.
Yeah,
Yeah.
so they can go green. They can go all sorts of colors.
Okay, okay. So, Maisha, what's the meaning of your name? Because that's a quite unique name that I'm hearing.
It means life.
Oh, that's nice.
Yeah.
Maisha. Okay. And Maisha, you're in year 12, right?
Yeah.
Okay. What's going on in your school?
Maths. Well, I'm doing maths, physics, and chemistry,
hmm
and I'm struggling right now with maths.
Not with physics.
Physics is. I was doing physics work actually before the thing.
Yeah, because a lot of people literally tell me that they are struggling the most with physics.
Funnily enough, I'm not struggling. I thought I was, and I think the thing with physics is I don't know. I'm not struggling at physics.
So you're struggling in math?
Yeah.
In which kind of topics?
Uh, Not all the topics, but
hmm
mostly like the last like topics are year one pure mathematics.
hmm
So like
Differentiation, integration.
I've got yeah those ones trigonometric identities ratios binomial expansion and I don't struggle with it but sometimes I get confused with the quadratics like the way they ask the questions.
hmm In binomial
uh,
expansion.
yeah.
Okay, okay. And towards the last, then we have vectors, exponentials, and logarithms, differentiation, integration.
Yes, I haven't done logarithms or vectors yet
Yeah, they don't
but
do that in school.
yeah but maths is just complicated.
Okay, so have you started with statistics in your school?
Not yet.
And mechanics?
No, we've only started pure maths. I think we have vectors and logarithms, and then we finish pure one,
No, but
pure
I
maths.
don't think they will be doing in school currently. In most of the schools, exponentials and logarithms and vectors is not done. Like you can let me
Yeah,
know if they are doing it right now, but I think
yeah,
after the COVID thing, there have to be some changes in the curriculum. So even we are waiting for the official websites to make the announcement, and then accordingly, uh, there would be some changes in the curriculums. That's why vectors and exponentials and logarithms, these two topics have been put on hold for now.
okay.
Otherwise, different schools do it, of course. But in today's class, we are going to do the topic of differentiation. Are you struggling with this topic too?
Differentiate. I think differentiation is easier because it's in year 11 maths. So I've done it before.
Have you given IGCSEs?
Yeah, I did IGCSEs.
Okay, okay, yeah, because in GCSEs, differentiation is not there. In IGCSE, it is there.
Yeah, sorry, I was just putting my iPad on charge. I was about to die. I did the IGCSE instead of the normal GCSE.
Okay, and you did it for which exam board?
Uh, EdXL.
Okay, and right now you're doing for edXL again, right?
Yeah, EdXL. Pure.
Okay,
Yeah.
okay. So yeah, differentiation would be just like a click away, then I would say. Yeah,
Yeah.
right. Okay,
Yeah.
See, you must not have done integration in that case. If you understand differentiation, then integration is exactly the opposite of differentiation. And
Yeah.
telling you for year 12, like the year 12 differentiation becomes the basics for year 13 as well. If you've already done this part, year 12 part, I'll raise your level a little bit so that we can discuss year 13 part as well. One thing that I'm sure you would not have done is the differentiation using first principle in your GCSEs, right?
Yeah.
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 So the first thing that they do over here in the book is differentiation using first principle. That's basically understanding the concept of differentiation. Now tell me one thing, what do you understand by differentiation?
What do you mean by that?
Like, why are we differentiating? What do we mean by saying that, okay, differentiation of x cube is 2x square? What does that mean? Where does the concept of differentiation comes into picture?
Why?
Like, why? Okay, I'll tell you. See, you know the concept of your gradients, right? What does a
Yeah.
gradient mean?
The steepness or
The steepness, right? And how do you calculate a gradient?
dy over dx are different. Yeah. Oh, yeah.
Yes,
Differentiation. Yeah.
change in y over change in x. So differentiation is nothing but the gradient, right?
Yeah.
Now, when we talk about, we say y is a function of x, right? That's how we define y. On a
Yeah.
vertical axis, we represent y, that is the function of x. On a horizontal axis, we represent x. So if I'm drawing a straight line and I'm trying to figure out, okay, what will be the change in y over change in x? See, that's where the first principles come into picture. Like over here, you see at point A, I'm saying that there is some x0, right? X0, the initial value. At that particular point, let me say if I have x0, the value of the function is f of x0. At point B, what will be the point on the y code? Like, what will be the y coordinate? That will be f of, since instead of x, I have x0 plus h. Right. It would be x naught plus h. Right. So technically, what's the gradient over here? Change in y. What's the vertical change? F of
It's going to
x0
be
plus h.
minus
My
f of x.
right. And what's the horizontal change?
The horizontal change is x. Oh
Hmm.
no, it's going to be x plus h
Hmm.
brackets minus x. Oh,
Right.
x0.
Right. And x0 minus x0, that's just 0. Right.
Yeah.
So we can delete it. And I'm
So
just
we just
left with
there's
h.
the h.
Right. Now, this h is a really very small quantity. What exactly are we doing from point A to point B? While I'm moving in the right side, I'm increasing my value of x by a very, very small quantity. So small that I can also say that h is approximately 0. It's not exactly 0, like if I say 0.000005. That's also
Yeah.
a very small quantity, right? So that's what I'm trying to say. So that's what we mean when we are saying limit h tends to 0. That's the notation, right? So this is my gradient. And that's how I'm going to say that I'm going to find out the derivative of any function. This represents derivative or gradient. This is called as differentiation using first principle. So in your exams, you will have questions like show that this is the differentiation of this function is equal to that by using first principle, or they can use these three terms as well. Euler's notation, Leibniz notation, Lagrange notation. These are just other names, but mainly in your exams, they give you words like first principle. All right. So you know that, okay, in your school you would have studied derivative of x square. That is 2x, right?
Yeah.
Yeah, but why, how? What if I ask you to prove it? How can you prove that the derivative of x square is 2x? Where are we getting this from? Why am I saying that, okay, x square is a graph, right? A U-shaped curve.
Yeah.
Now, if I want to calculate the derivative of x square at any point, how do we calculate the derivative of any curve? We draw a tangent at that curve and then we calculate the gradient of the tangent. Why am I saying that whenever I'm going to draw any tangent, it would represent the line 2x? We can prove
Because
it by this using first principle. I'll show you how. Okay, like over here in this case, the point A with coordinates 4, 16 lies on the curve with equation y equals to x square, right? That means my function f of x, that's equal to x square. If I want to figure out the gradient, that means I'm calculating the derivative, right? In
it's
your
going to be 2x.
questions, sorry?
So the gradient will be 2x.
Yes, but that's not what they ask you to show in the A
Oh,
part,
so,
right? So in these kinds of questions, wherever you see limit, okay, that means differentiation using first principle. You know that the rule, right, that I just told you. Limit h tends to 0, f of x plus h minus f of x over
minus
h.
h.
So instead of x, if I write x plus h, that means it would be x plus h squared, right? My
Yeah.
function of x is basically the square of it. So whatever is written inside the brackets, I'm going to square that up. This is what it means. And divided by h. Yes?
Yeah.
Now can you expand the brackets?
Yeah.
What will it be?
It would be x squared.
Hmm.
Wait, let me do it quick.
Yeah, sure.
X squared plus 2xh
Hmm.
plus h squared.
Hmm. And then there is a minus x square as well. X square minus x square. That's just going to be 0, right?
Yeah.
And then I'm left with h square plus 2xh. Now you see h is common, right? I will
Yeah.
not apply the limits until and unless I have h in the denominator, because I cannot have 0 in the denominator. So my
Yeah.
trial would be in such a way that I can just cross out this h in some which ways, right? So what I can do is I can take out h common from the numerator and h divided by h. That's just 1. So we're talking about the gradient. Just a second. Yeah, there you go. So this is
Yeah.
the
It's coming
question that
through.
we were doing. So f of x was x square, right? And
Yeah.
we were doing limit h tends to 0, f of x plus h minus f of x over h. This was the
Yeah.
rule. So x plus h whole square minus x square over h. So we had written it in this way, right? And then we said
Yeah.
that h is going to get cancelled out. So we have h plus 2x over h. Yeah, this gets crossed out. So limit h tends to 0, h as it is, and see the coordinate that is given to me, that's 4, 16. If you look at it, this is x comma y, right? So what's the
Yeah.
value of x that you have?
4.
So that means 2 times 4, 8
8.
plus h,
Yeah.
and that's
Oh,
what we
yeah.
needed, right?
Yeah.
So remember, whenever in your question they're talking about gradient, you need to calculate the derivative. But in the question, if they ask you to show that this is the derivative, that means that like you have terms of limit. That means you have to apply the first principle.
First
Now,
principle.
the B part says that you have to deduce the value of G. That means just substitute h equals to 0. So this is the gradient. Limit h tends to 0, 8 plus h, which is 8 plus 0. So that
0.
means 8.
G8.
Right. So my gradient is coming out to be 8. And that's my answer. Technically, if you use your concept of differentiation, you know derivative of x square is 2x. And x is 4. That means 2 times 4, 8. Right? So that's
Okay,
how
yeah.
we get that the derivative of x to the power n is nx n minus 1. I'll show you one more example. Like this one is for cube, right? You can use your cube one as well. Try it right now. F of x is x cubed now.
X cubed, and then that means it's going to be.
I've written the rule for you on the screen. Apply the rule.
Yeah, I've just write. Yeah, I've just write the rule down.
Yeah.
Minus f of x over h, and then that would equal. So then, yeah, you got x plus. So if the x is cubed, does that mean also you know the f of x plus h? You just do the whatever that is to the power.
Right. X plus h to the power 3.
Yeah.
Yeah. So you would
Okay.
do x cube plus h cube plus 3x square h plus 3x h square. That's what you get when you expand a cube bracket, right?
Yeah.
If you have learned a few formulas, then these kinds of calculations become really very easy. Like if I talk about doing a plus b squared, square of two terms which are being added. That means square of first term plus square of second term plus twice of first term times second term. If there is a negative sign in between, now see, the square term does not get affected, only a minus over here. If I have a cube, so that means cube of first term, cube of second term, plus 3 times square of a plus b plus 3ab square. Similarly, you can
Oh.
have for minus sign as well. A minus b whole cube. A cube minus b cube minus 3a square b plus 3ab square.
I didn't know that.
Yeah, these are a few formulas. Like your calculations become very faster if you have learned these four formulas. You see your squares are being expanded almost every now and then there are these cube terms as well, right? Even in your like year 13, you would always have questions where you're expanding squares or something. I feel that these make our life very very easy.
They do.
Yeah,
Yeah, I've never been taught this.
you can write them down.
Yeah.
And one formula that you would have done in your GCSEs as well, a square minus b square, difference of two squares, right? So that
Yeah.
is a plus b times a minus b. What was your grade in your GCSEs?
8.
Oh, that's nice.
Yeah. But A level maths is. Oh.
No, it's easy, I would say. It's just that you need a lot of written practice, right? By
Yeah.
your age, I would say that we tend to have that kind of um, practice that, okay, we are looking at a question and we are solving it either mentally or just by looking at it, right? That's become
Yeah.
our habit. So I would say that until and unless you write something on your own, till that time you're just grasping the concept. But to know if you're able to do it by yourself, you need to write it out, right? And since we are out of habit of writing, we write it directly in our exams and then we know, oh, I didn't understand this concept.
Yeah.
Yeah, so I would rather suggest you that try to practice it by writing.
Yeah. Okay, I wrote that down.
Okay, so coming back over here, try this out. X cube minus x cube gets cancelled. Now see if you can take out h common.
Yeah. Yep. And then
Now what's
after
the value
the,
of x that you would be getting over here?
you would plug -2 into the equation.
Right.
So that would be h squared plus 3 brackets -2 squared plus 3 -2h. And then that would be h squared 12 plus -6h.
Correct. And that's exactly what we needed in the A part. Right. Now my B
Oh,
part, yes.
okay, yeah.
Yeah. Now my B part says deduce the value of G. All you have to do is substitute H as 0. That means G equals 12.
So, yeah.
Now,
Yeah.
yes. Now, technically, if you apply your concept of gradient, what is the derivative of f of x?
In this situation,
Mm-hmm.
so if the gradient is f of x is x cubed, so it can be 3x
3x squared. You
squared.
reduce it by 1, and x is negative 2, right? So you're
Yeah.
technically getting 12, right? The first way is
Yeah.
just the longer way. So you just have to use it when the question gives you again like this limit h tends to 0, right? Otherwise, we are not going to use it much. Okay, now coming to the next part, that is using differentiation rules. Now, see, by the questions that we have discussed, you can also try it and you can prove it out. But for trying this one, to prove that if the function is some power of x, right, then the derivative is this power comes in the front and gets multiplied,
And
and
then n minus 1.
right, you reduce it by 1. You can try proving it by the first principles as well. And when you try that, you will have to use binomial expansion
Binomial.
because you're doing it in general, right? So
Yeah.
that gets a little tricky again. So they won't ask you the proof of this. They would either give you terms of x square or they would give you x cube, not even power 4. That's what they can give you in the exam, right? Now, one thing you would have also studied that if I have the function as, let's say, just 5, what's the derivative of 5?
There is no derivative because it doesn't have an x.
Right, so it's 0, right?
Yeah.
Yeah, but technically, how do we show that the derivative of any constant number is 0?
I don't know.
Let's say I have a function, let's take 5 only. Can I write 5 as 5 times 1?
Yes.
So tell me one thing. Can I write 1 as x to the power 0?
No.
Why not?
Because
The way you
actually true
said,
because
the way you
because
said no, you reminded me of a meme. That meme was like women rejection without reason.
no, you can write it like that because anything to the power of 0 is 1.
Right. Anything to the power 0 is 1, so I can replace 1 by x to the power 0. Now, while taking derivative, what do we do? Keep the number as it is. Derivative of x to the power 0. That means this 0 comes in the front and the power reduces by 1. Anything multiplied by 0 is just 0. I got my derivative as 0.
Yeah.
Right.
Okay,
So if you take any number, like let's take a constant k, you can always write it as k times x to the power 0. And each and every time when you are differentiating this kind of an expression, like x to the power 0, this 0 would get multiplied and will make the derivative as 0. All right?
yes.
Yes, great. So now trying out a few questions. What would be the derivative of x to the power 8?
8x 7 to the power 7.
Right. What about this fraction now?
3/4 x to the power of, that would be a quarter.
Negative quarter, because 3 over 4
There's,
minus
yeah,
1, right? So it would be negative quarter, right? What about the next one?
that would you have to change how it's written?
Yes.
So that would be x to the power of 3 over 2?
Mm-mm. This is like cube root of x. Cube root of x means x to the power 1 over
A
3.
third.
Yes. So now when you differentiate it, it would be
So it
1
would be
over
a third.
3.
And then it's going to be minus 2 over 3.
Correct. Sometimes you may even have to simplify it, like in this way. First, let's keep the third as it is. This is 25, right? When I cross it out, 10 divided by 2 is 5. 5 times 5,
Yeah.
25. Then x to the power. Whenever you're multiplying your numbers, the indices get added, right? So 4
Yeah.
plus 1, and whatever is being divided, the indices get subtracted. Square root of 25, that's just 5. Then square root of x to the power 4 plus 1 is 5, 5 minus 2, 3. So
Yeah.
this is 5x to the power. Now it is 3 over 2,
3 over 2.
right?
Yeah.
So now when you differentiate it, you get 5 times 3 over 2 x to the power 1 over 2,
2.
right?
Yeah.
Okay, now moving on to the next one. I want to find out the derivative in this case. Now see, although in year 12 you haven't done a chain rule, but in year 13 that's like really very important, and in almost every question you would be using it. I'll tell you, in your final A level exams, they give you questions which are of mixed form. Right now you would study like, okay, what's the differentiation when you do x to the power n, what is the derivative of cos. Then in year 13 you would do product rule, quotient rule, trigonometric differentiation, all of that.
Yeah.
And then in your exam they will make one such question in which all your concepts would be applied, like literally all of them. Like some question like cos x cube, and they would find it like square, and you would be using chain rule over here. If I multiply it, you would be using the product rule also over here. Everything. So right now we are just grasping each and every concept individually. Now, what will be the derivative of y square?
2y.
What's the derivative of x square?
2x.
Correct. But tell me one thing. When we write dy over dx, and I'm calculating the derivative of x square, see, you have x in the denominator. What does this mean? You must have heard your teacher saying in the school that find the differentiation or derivative with respect to x.
Yeah.
Yes. So what does that with respect to x means? Are we giving special respect to x? Yes. Technically, why? Because the function is in terms of x. But if I'm doing y square, I'm not saying that I'm differentiating with respect to x, right? Technically, I can find the derivative of x square and write it as 2x. But for y square, I'm saying that you have to again differentiate in terms of x only, right? So technically, yes, it is 2y, but you're calculating the derivative of y, right? So you would extend it because y is a further function of x. So you will write dy over dx. That's a little bit concept of chain rule, which you'll be studying in year 13. But for now, one thing that you can remember is that whenever you're finding out the differentiation and you have to find out the derivative of y cube, or you have to differentiate with respect to x, you differentiate it like you normally do and then write dy over dx along with it. So over here, if I want to differentiate, so let's say we are differentiating both sides. That means we are doing 2 times derivative of y square 2y. But since we are doing it with respect to x, WRT means with respect to x. So I'll write dy over dx. And I do not need to write anything while differentiating x cube because that's a term of x only. And the derivative of 0 will be simply 0. So I get 4y dy over dx is add 3x square and divide by 4y on both the sides. Alright, now technically my question is 2y square minus x cube is 0. That means what's the value of y that we are getting from here? We can say y is square root of x cube over 2. So you can substitute this value. If your question says that you have to find out the answer in terms of x only, you can differentiate it, right? Sorry, you can substitute it. So 3x square surd 2 divided by 4x to the power 3 over 2. If you want to simplify, see, you have x square on the top, right? You can use your rules of indices. X square and x to the power 3 over 2. So, yes, you would subtract. So 2 minus 3 over 2, that's 0.5. So half over 4. Just go through this entire calculation and see if you have any confusion in this part.
Okay, I
Done?
understand it.
All right,
Yeah.
great. So, any confusion in whatsoever we discussed today so far, Maisha?
No.
Understood everything? What did we discuss? We did first principles, right? Differentiation using first principle, in which, yes, I told you how are we actually calculating the derivative? Point A over here, point B. So this is x0,
x0 plus h.
right? Then this is f of x0 and
that would be f of x0 plus h.
correct. So if I want to find out the gradient, which is the derivative, so what formula did we get?
You had, lim, and then you had f of x plus h minus f of x over h.
Correct. That was differentiation using first principles. Then we did 2-3 questions in which we showed derivative of x square, we got 2x. Derivative of x cube, we got 3x square. So in general, we got the derivative of x to the power n. See, when we are talking about derivative, the small dash on the top represents differentiation. So that's nx n minus 1. Right? And then we discussed how we can use it in certain questions, right? So that was a little bit of basics of differentiation we discussed today. Any doubts, any confusion?
No.
All right, great. So now I'm just going to quickly tell you about the methodology that we follow up at GLECTA. See, over here we provide recorded lessons as well. So if in case once you enroll with us and you miss out any lesson, you can view the recorded lesson on our website. All right, every lesson is a recorded lesson and that's accessible only to you. All right, and apart from that, on Google Classroom, I'll be giving you assignments. Like if we discuss the topic of differentiation today, then on the upcoming Saturday, you would receive an assignment from our end in which there would be some, like, let's say, past year paper questions of differentiation only. So, my main aim is for your final A levels, right? Along with your AS levels. I'm trying to make your base in such a way that you do not feel problematic in year 13, right? So for that, I'll be giving you the past year papers right now here itself, right? I mean, like in year 12 itself. So past year paper questions on every Saturday. They're for your own practice. All right. Anything that you would want to ask?
with the normal like lessons, would it just be myself, or would there be other people as well?
That depends on what kind of group you enroll in, because we
Okay.
provide, right now it was a trial lesson, so that's
Yeah.
why it was one on one, so that I can ask you what specific thing are you looking for, what's your specific requirement, so that it can help us in placing you in the right batch. Right, we
Okay.
provide group of 2, 3, 5 and 9, and of course the
Okay.
cost of every batch is different. Group of 2 would be different, group of 3 would be different, right? So you can talk
Yeah.
to the management accordingly. What would you prefer? Would you prefer a group of 3, 5, 9, 2?
I'm not. If I don't mind.
Okay, okay. So you can talk to
Yeah.
the management, not a problem. Right now, a few new batches have also started, so you could be placed in those batches as well. So, as I said, now I know that your exam board is Edexcel, right? So, that's the main thing. That's how we place the batches, right? According to the exam
Yeah.
board and as per the, the, what do we say? The the curriculum that is going on right now, right? So that's what we'll be doing. Okay?
Okay. That's fine.
Yeah.
Yeah.
Okay, so you can talk to the management if in case you have any problem or any doubts. I'll just ask the management to give you a quick call, and I think they will be calling you up after the class itself. Not right now, I'm
Okay.
not sure, but
Yeah.
they would give you a quick call, and if in case you have any questions regarding the schedules, the timings of the lessons, you can ask them. All right?
Okay. Yeah, that's
All
fine.
right, Maisha, that would be all for today. All right?
Thank you.
Okay,
Yeah.
bye-bye.
Bye. Thank you.
Bye.